Welcome to Automate 2025, Day 3. First, thanks for being here. Really appreciate it. We're kicking off today by turning our attention to one of the most dynamic forces in the automation space, automotive innovation, and how it's driving change across every industry. Here to get us started is someone who's been at the forefront of industrial automation for over 3 decades. I probably should have said that out loud. Chuck Ridgeway, Automation Technology Manager at Horner Automation. Chuck has spent 35 years helping companies adopt smarter and more connected systems, especially in sectors like automotive, food and beverage, oil and gas, and agriculture. He began his career in Michigan's automotive industry as a field application engineer and has worked with automation users all over the world. Today, he'll explore how developments in the automotive world are shaping the broader future of automation. Please put your hands together for Chuck Ridgeway.
Okay. All right. Thanks, everybody, for joining us today. We're just going to have kind of a fun, informal conversation about kind of how some of the advancements in automotive technology apply to automation over time. And it's really pretty interesting. The company I work for, we are a manufacturer of automation products. We're not an integrator, like our name might suggest to some folks. So what we specialize in are PLCs with built-in touchscreens, kind of all-in-one components that are used in a lot of OEM machinery. That's kind of what our company does. And what we find is as we develop our automation products over the years, a lot of the technology that starts out in automotive is what ends up in the automation sector. So I wanted to kind of explore that with you today. You know, what's been in use, maybe what's currently in use, and what's coming down the pike. It's really pretty interesting, but it's a pretty informal conversation. So I know a lot of us think of automation as being a pretty good sized market, and it is, okay, but it's not the biggest market, right? So as an automation manufacturer, we often find ourselves applying components that were developed originally for other industries, okay? So for instance, if we talk about some of the other markets that are around. So we think of automation as being a pretty good sized market, but if you just look at integrated circuit usage, you'll see that we're quite a ways down the line there compared with consumer electronics, computers, automotive, and then finally down to automation. So yes, it's a large market, but what happens is component manufacturers will design for those larger markets first because that's where the volume is. And then, you know, by the time they get down to automation, there's not as many components that are designed specifically for automation. So as an automation manufacturer, what we end up doing is we end up picking, in certain cases, components that were developed for other industries, okay, as kind of a starting point for our products. And there's good reasons for that, okay? Economies of scale, first of all. Those other markets are larger. They have large volumes, so that drives lower cost, right? Drives a lot of, lower cost for the components. Also, proven technology. What tends to happen is those other industries move a little faster, especially consumer electronics and computers, automotive to a certain extent. So by the time we apply them in automation, those components and technologies are well proven, which is important, right? Our factories have to be incredibly reliable. All right, so there's good reason why we apply components that maybe were developed for other industries. And automotive is really the other high volume industry that matches up the best with automation, okay, for a variety of reasons. The design for ruggedness. The automotive environment is very difficult. Whether you're talking about integrated circuits, whether you're talking about mechanical parts, there's high noise, it's a tough power environment, a tough temperature environment. All those things make those components designed for automotive to have to really withstand those sorts of environments. And automation can also be a tough environment. A lot of those same noise issues and temperature issues and those sorts of things can occur in automation as well. Another big reason is because automotive life cycles are longer. So you don't have a new model developed every single year. Yeah, it'll be a 2024 versus a 2023, etc. But the difference, but a typical car model will run for 5 to 7 years. So you've got longer design cycles there. Consumer electronics, computers, those tend to turn over much more quickly. In automation, when we install a machine or you install a machine using our components and other manufacturers' components, that machine needs to be reliable for 10 years at least, right? And you can't be redesigning with new components every year as a machine builder, and we can't be doing that as a automation manufacturer either. So those longer life cycles are really important. So again, those are a couple reasons why automotive components line up really well with automation. So we're going to kind of explore some of the different areas of automotive innovation, which we've been able to take advantage of over the last few years in the automation industry, and kind of what's coming down the pipe as well. Okay, so we're going to start with CAN. Now, some of you who are familiar with CAN are kind of thinking, well, wait a minute, CAN is an older technology. Its application in factory automation is going down a bit, which is absolutely true. It's being replaced by other technologies, but we'll talk about those other technologies in a bit. But as a little bit of a history lesson to kind of illustrate my point on economies of scale and those sorts of things, let's start with CAN. CAN has been, for many years, the primary on-vehicle network for automotive. Okay, so typical car these days is going to have anywhere between, 30 to 70 different nodes on CAN networks on your vehicle, typical family vehicle, spread out over 5 or 6 different CAN buses. And luxury vehicles and bigger vehicles will have more than that. So obviously, in a network environment on an automobile is very difficult for all the reasons I've mentioned before. The noise immunity issues, the voltage issues, all that sort of thing. If we take a look at CAN, just to kind of look backwards a little bit, and again, it's still the dominant network today, pretty much pretty close lockstep to when CAN was first applied on the vehicle or became standard on the vehicle. In automation, we adopted it. Okay, now, the technologies that were adopted and still remain today are networks like CAN Open and DeviceNet, which were big 20 years ago. And you're thinking, well, what's new about that? Well, the big point I'm trying to make here is that today even there are 2 billion with a B CAN transceivers that are manufactured. So that gives you an idea of just the scale of the magnitude of the economies of scale that automotive type components can offer in the automation industry. So as we go beyond CAN and automation, as we've kind of already done so, or started that direction at least, you can see that what's happening on the automotive area from networking can really impact us in the automation world. So CAN is based on a bus topology, makes wiring less wiring, devices hanging off of a single bus. There's a lot of good reasons why that works well in an automobile. And as a result, I said there were 2 billion CAN transceivers. Also, just about every microprocessor and microcontroller from 50-cent units to $60 units as a component, they all have CAN built into them. Doesn't mean it's applied on every application, but just gives you an idea of how widespread those sort of automotive technologies can become over time. All right. Now, okay, why are we talking about CAN? Why aren't we talking about Ethernet, which is pretty much what we've moved to on the factory floor, or we've in big numbers over the past several years, and what's happening with Ethernet on the automobile, and how maybe could we apply some of that to the automation industry, okay? Well, basically, if you go back to the 90s, and there was a lot of concern in the automation industry about Ethernet. Is it deterministic enough? Is it rugged enough? Is it going to hold up in a factory environment? And over the years, obviously, we've made several innovations. It's evolved, it's adopted, those sorts of things. But it's only been fairly recently that Ethernet has really started to show up on the automobile. And to really take advantage of some of the capabilities of Ethernet, the automotives have made some customizations to Ethernet that I think are going to really start showing up in the automation world. They already have to a certain extent, but one of the changes that we have with automotives and Ethernet is the development of automotive Ethernet. So what is automotive Ethernet, and how does that differ from Ethernet that started out in the computer industry that we've been using and evolving over the past 20 and 30 years? Well, the big difference is in the physical layer, as you would expect. Automotive environments much more difficult than other, computer environments or consumer electronics. So changes to the physical layer were a big thing that's been done in the automotive world. Your typical Ethernet communications is 2 twisted pairs, one for transmit, one for receive. In automotive, they've got it down to a single pair Ethernet. Okay, so full duplex communication. Okay, that goes from 2 twisted pair down to 1. What's the big deal about that? Well, weight of wiring in the vehicle is a huge issue, right? So you need to eliminate as much of the wiring weight as you can. And by going full duplex, they've reduced it in half. And also, in some cases, many cases actually, power can also be distributed over that same conductor. So now you have one conductor that's not only handling the communications, and it can get up into some pretty fast speed in certain cases, but also it can handle power. So that's definitely something that we're starting to take advantage of in the automation market, and I would venture a guess that we're going to do so even more in the future. Now, if we take a look at the different topologies that are available for automotive Ethernet, that's important because multiple topologies are really needed on an automobile, and we have multiple topologies in the factory as well. So today, at least on the automobile, what's still dominant is single pair Ethernet point to point. Okay, one device talking to another device at high speed, no switch in between. They need the high bandwidth maybe for some of the autonomous data and those sorts of things. So that's still a dominant approach for certain peripherals in the car today. But there's also the star topology that we're familiar with, that's the most common in the computer world and the most common in the automation world, and that is where all of our Ethernet level devices are connected to a switch in a star topology. And even with automotive Ethernet, you can see speeds up to 10 gigabytes. So there is lower speed stuff, but there's also higher speed available as well. And then there's also the bus environment. And this is really designed so that those lower level devices, the sensors and the actuators, the really lower level devices that today are on CAN or even one of the sub-networks of CAN, can then be adopted to Ethernet, now at a much lower speed. You can see there that's really single paired only at about 10 megabytes, but that's still as fast, if not faster than CAN, and it has the advantage of having all the devices actually on Ethernet, even though it's a bus level of Ethernet. So if we take a look at potentially where things are headed in the automotive world, if you take a look at your car here, where things could be headed with an all Ethernet type design, what you'll find is a mix of the different topologies on the vehicle. So your sensors and actuators, your really inexpensive stuff is going to be on the bus level, Ethernet up to 10 megabyte, but then you're going to have star level devices, you're going to have devices talking point to point, you're going to have a mix of low bandwidth stuff with some really high bandwidth stuff for some of those autonomous requirements and those sorts of things. So, and one of the real advantages of this approach is having everything on Ethernet is now the addressing scheme is consistent throughout. And things like firmware updates of simple devices that, yeah, they're going to need firmware updates maybe at some point. Those are a lot easier if everything is interconnected and accessible from a central location over Ethernet. So there's a lot of real advantages to this. That's not where things are necessarily at today everywhere, but that's one of the visions of where things could be happening. And a lot of this approach, or some of this approach at least, could be applicable in our automation world coming up. So, how could this be applied in the automation world, and how is it being applied today? So with single pair Ethernet and power over single pair, suddenly now sensors and actuators and really simple devices have even more options in terms of how to interconnect over Ethernet to machines. And single pair Ethernet's already being applied for hazardous location devices where you need to have a barrier, an intrinsic barrier between devices. When you have a single pair with communications, those barriers become a lot easier at that stage. So it's already being applied in the hazardous location area of automation, and we expect to see a lot more of single pair Ethernet in the industrial space over the next 10 years or so, getting even larger over the next few years. Okay. The next area I want to talk about in terms of how automotive technology has benefited the automation world is we're going to talk about LCD touchscreens. Now, to a certain extent, it's really more the consumer electronics, probably as much as anything else, along with automotive, that has provided the benefit of the economies of scale for the increased availability of LCD touchscreens in the automation world, okay? We've had LCD touchscreens, for 20 years in automation, but the way prices have come down has been really pretty amazing, and a lot of that has because of not just the explosion in the consumer electronics world, but also how the automotive manufacturers have adopted LCDs now with digital dashboards. So it's not just your radio anymore or your infotainment system, now it's digital dashboards and everything else. And how has that benefited the automation industry. Obviously, the most obvious one is economies of scale, right? It's incredible how much prices for 7-inch and 10-inch and larger HMIs and other products that have built-in touchscreens in the automation world, how inexpensive those are today versus even, let's say, 5 years ago. And a lot of that, some of that is coming from a volume driven on the automotive sector, some of that from the consumer electronics sector. However, not all displays that are developed for consumer electronics are applicable for automation. There are environments where that's just they're not rugged enough. They're not viewable enough in a tough environment, high sunlight, those sorts of things. So the explosion of the digital dashboards and those sort of things in the automotive side of things has meant some higher quality, more ruggedized, easy to view and sunlight type LCD panels are now available more than ever. And so now for those outdoor automation applications or mobile automation applications, there are much better choices available. So you can actually see the touchscreen as you're trying to operate that equipment outdoors, where, maybe 5 and 10 years ago, finding a really outdoor viewable touchscreen has been a real challenge. Nowadays, they're just starting to get into the mainstream, so it won't be such a big issue moving forward. If you've got an outdoor automation application, you'll be able to find an LCD that is not going to be the least expensive, but it will be one that will work in your application, and there'll be more choices than ever. So that's another area that's been approved. And another thing that's really happening in automotive that we're going to start to take advantage of in the automation world is the way that video products are interconnected. Okay, and now we're not just talking about LCDs. Now we're talking also about cameras. Okay, because we all know in cars these days, there's cameras all over the vehicle, and what's happening in automation, we're going to see more and more cameras in our automation as well. Okay, so the way that the cameras are interconnected on the vehicle is definitely a technology that we'll be able to take advantage of in the automation world. And again, not just cameras, but also LCD displays. So there's a technology called flat panel display link, which is used very heavily in automotive. It's used in some other sectors as well. On your laptop, the hinge where your screen meets the rest of your laptop, that uses FPD-Link to get a signal across safely and reliably across that hinge. Basically, the way FPD-Link works is it takes what typically would be a parallel type connection with a lot of individual signals, and it serializes it down to a single twisted pair. And it also includes power and control signals and other lower speed signals right on the same cable. So now you can interconnect cameras and displays over, say, a 4-conductor coax type wire that has the video signal, the touch feedback from the operator, some control signals and those sorts of things, allowing you to very easily distribute cameras for video sources as well as displays for interaction with the operator. And it contains the touch information, feedback, and all that as well. So in our company's case, we've taken advantage of FPD-Link to release the first FPD-Link based touchscreen. So what my company is known for, and I mentioned at the opening, is all-in-one controller. So a PLC with a built-in screen, built-in I/O, one component, very often used with OEM type machinery. What we're able to do with FPD-Link, and other companies will in the future as well, is basically to separate the touchscreen strictly as a component. So there is no, this is not an Ethernet connection. There's no program or configuration required in that component. That's just literally a touchscreen component. You can locate wherever you want to on the machine within about 50 feet or so, 15 meters. And again, it's in our application, we're able to distribute up to 3 touchscreens back to a single controller. And one of our key customers who's using this technology, we co-developed it with them. They're in the emergency vehicle industry. So they're doing automation on fire trucks and ambulances and those sorts of things, which needs an extremely robust connection for all their devices. And obviously that's one way of accomplishing that, taking advantage of automotive technology. Okay, and then of course, as I've mentioned a couple times already, the explosion of cameras in the automation world. Today a lot of the cameras are distributed using Ethernet technologies, and that's not going to change anytime soon, but you're starting to see FPD-Link cameras, high-resolution cameras being used with vision systems, robotics, AGVs, those sorts of things. So you'll start to see more of that technology. Basically what you have is a very high definition, high speed video signal being sent over, effectively a simple cable that's very rugged, and you're not losing any bandwidth or any of those sorts of things. So it's a technology you're going to start to see more of in the automation industry. Okay, so to kind of wrap up here over the next couple of minutes, I'll just mention some of the other technologies that maybe some of them are a little more obvious, some of them not so much, that the automation manufacturers like my company and others have been able to take advantage with some help from the automotives. So GPS obviously is one of those. And one of the great things about GPS these days is you can get accuracy tracking down to the centimeter level now. Okay, so now that starts to become more applicable in automation maybe than it was in the past. It's always been at least somewhat applicable, but now that you can get down to that level of tracking, that's a big deal. So as we all know, in certain applications, GPS is a key technology for automating agricultural applications and plenty of others. And then there's some maybe less obvious applications for automotive components in automation. Power supplies. The automotive power environment is really tough. 12 volts, lots of noise. You have batteries draining. You have cranking of your when you start the vehicle, and a lot of automation companies, including ours, have taken advantage of power components that were developed for the automobile, using them in factory automation products to make them more reliable, especially in those mobile and maybe agricultural and other similar applications where you're running maybe with a battery backup or something like that. Also, high current output circuitry that's very important in automotive, LED drivers for headlights and other things. Those are all components that are actively being used today underneath the hood in the automation industry. And then, of course, not to mention all the different mechanical materials, the gaskets, the rubbers, all that sort of thing. Our automation products today are all using all of those materials that have been developed a large part for automotive because of the tough environment that automotive has to offer. Our automation products can take full advantage of that. And then finally, conformal coating, overmolding. That's been a way of life in the automotive industry for years, and we've been adopting it in automation for some of the tougher environments. So hopefully that was an interesting discussion, and you saw some of the technology that's in use in the automotive world, that's on its way to the automation world, or it's already here. And as you kind of keep an eye as a technologist, which most of you probably are, keep an eye on what's happening in the automotive industry from a technology standpoint, because there's a pretty good indication that that's going to apply more and more to automation over time. So thank you very much.
So Chuck, where is your booth? Can you point us in the right direction?
So it's in the last row, right? And just keep going to the right, and it's in the 7,000s, right?
7025.
There we go, 7025.
So front right-hand corner.
Yeah, and we're demonstrating that FPD-Link, flat panel display link, to separate that touchscreen from the control. So if you're interested in taking a look at that, come visit us.
Great. Big round of applause, please. Thank you, Chuck.
Okay, thank you.